In this video, we're going to learn how to name and write formulas for ionic compounds. So when we do this, we're going to follow the three-step approach. First, we're going to write the formula for the cation and the anion, including their charges. Then we're going to check to see if the charges are balanced. If they're not, we're going to balance the charges using subscripts. We'll use parentheses if you need more than one of a polyatomic ion. And we're going to use the crisscross method to balance the subscripts. Let me show you how this looks. So here's an example problem. Barium nitrate. So I need to write the symbol for barium. Barium is Ba, and it's in group 2, so that means it'll have a 2+ charge. Then I need to write the symbol for nitrate. So it ends in 8. That should tell me that it's a polyatomic ion, and I need to go to table E to find that. So if you go to table E, you'll find out that nitrate is NO3, and it has a -1 charge. So step 1 is done. We've written the symbols for the cation and the anion, and we have their charges next to them. Step 2, we need to check to see if the charges are balanced. Does a 2+ balance out a 1-? Now you might see this 3 here and think this is a 3 1-, but no, this all acts as one unit. This NO3 together has a 1- charge. So the answer is no, this is not balanced. A 2+ will not balance out a 1-. So we need to use the crisscross method to balance the charges. So I'm going to take this 2 and cross it over here. Now I can't just cross the 2 and write it next to the 3. If I did that, it would look like I had 32 oxygens, and that would be silly. So I want to put parentheses around my polyatomic ion before I do this. So I put parentheses around the nitrate, and then I write the 2. Written this way, it says that I have 1 barium and I have 2 nitrates. Now when we check to see if it's balanced, a 2+ is balanced out by 2 -1s. 2+, 2- is neutral, and all ionic compounds like barium nitrate will always be neutral in the correct formula unit. Let's do another one. Ammonium sulfate. So ammonium is not something you probably recognize because it's not off the periodic table. This is again a polyatomic ion. You need to go to table E to find ammonium. And when you find it, you'll see that it's NH4 with a +1 charge. Sulfate ends in 8, so that's also a polyatomic ion. That is SO4 with a 2- charge. A 1+ does not balance out a 2-, so we need to balance them. So we need to crisscross. Now this 1 that's really here does not need to cross. Remember, you never need to cross a 1 because it won't change anything. I already have 1 sulfate, or else it wouldn't be part of the formula. But this 2 needs to cross over here. Again, I want to write parentheses around my polyatomic ion so I'm not confused as to how many I have. By writing parentheses and then putting the 2 down there, it says I have 2 ammoniums for every 1 sulfate. When I check to see if it's balanced now, it is. I have 2 1+, 2 ammoniums that are both 1+, will balance out 1 2-. Okay, sometimes you'll have a compound that contains a Roman numeral. So this is a transition metal that has multiple oxidation states. So this makes your life easy. So iron with a Roman numeral 3 tells me the charge. So there's no guessing games here. It tells me my iron, the symbol Fe, is going to have a 3+ charge. Chlorine is Cl, and it always has a -1 charge. The 3+ is not balanced out by the 1-, so I'll need to crisscross. So I just need to cross the 3, not the 1. I'll bring the 3 down over here and write it like this. Now you don't need parentheses in this example because it's not a polyatomic ion. If you put parentheses, technically it wouldn't be wrong, but it's also not the right way to do it. So you should just write it the way I have here. FeCl3 is the now balanced formula unit. Next, we have aluminum sulfide. Hopefully you're getting the idea by now. Why don't you try this one on your own? Okay, let's see how you did. So aluminum is in group 13, so it has a 3+ charge. Sulfide, if it ends in I, that will tell you that it is off the periodic table. This is just an ion of sulfur. Sulfur is in group 16, so it would have a 2- charge. The 3+ does not balance out the 2-, so I need to crisscross both of these numbers. So I'll cross the 3 over here and the 2 over there. It is now balanced. So this is how you can write your answer. You can leave it like this. A lot of kids in the past think for some reason they need to rewrite their final answer without these charges, this 3 plus and this 2 minus. So they'll do the work and they'll do the crisscross and then they'll write it again without the charges. In my opinion, that's just a waste of time. There's nothing wrong with leaving the charges on top. I actually prefer it because it shows me that you're doing the work properly the way you're supposed to get the right answer. Okay, let's do another one. Magnesium carbonate. Magnesium is in group 2, so it has a 2 plus charge. Carbonate, the 8 ending, again, bells should be ringing. This is a polyatomic ion off of table E. That is CO3 with a 2 minus charge. When we check to see if the charges are balanced, the 2 plus is balanced out by a 2 minus. So there's no need to crisscross here. In fact, it's wrong if you do. It's already balanced, so is a formula unit, this would exist in a 1-to-1 ratio, MgCO3, just like this. If you crisscross the 2's, it would be Mg2CO3 in parentheses and then a 2, and that's not correct. You would actually get that wrong if you did that. So if it's balanced, you leave it alone. Your life's easy. Move on to the next problem. Our next problem is zinc hydroxide. So zinc is a transition metal, but it only has one possible oxidation state. If you look in the upper right-hand corner, you'll see that it's 2 plus. Hydroxide, although it ends in "ide", it is a polyatomic ion. So this is not an ion of hydrogen. This is off of table E. This is just going to come with practice and memory. Hydroxide is OH, and it has a 1 minus charge. So the 2 plus is not balanced out by the 1 minus, so we need to crisscross the 2 over here. Don't forget your parentheses. ZnOH2 is your answer. Now again, the parentheses are vital here. If you just crossed the 2 and left it, the way it would read would be 1 Zn, 1 oxygen, and 2 hydrogens, and that would not be correctly balanced. You need 2 hydroxides with that -1 charge to balance out one of these zincs. Okay, next we have aluminum phosphate. Aluminum's in group 13, so it is +3. Phosphate ends in 8, so that's a polyatomic ion. Off of table E, that's PO4 with a 3 minus charge. And for the second time here, we have something that's balanced. The 3 plus is balanced out by the 3 minus, and so it's already balanced and it's done. That's the answer, AlPO4. We also need to know how to name ionic compounds from the symbols. So if I gave you this formula unit, CaCl2, in order to name it, you need to name the cation first and then the anion. When you're naming the monoatomic cation, you just write the name of the element. So this is really Ca with a 2 plus charge. It's a calcium ion as part of this formula unit here, but we drop the ion and we just say calcium. Then we name the monoatomic anion, and this is the one that you name with the root name and you change to the "ide" ending. So chlorine becomes chloride here. This is a chloride ion as part of this formula unit. So this molecule is, I should say this formula unit would be named calcium chloride. Sometimes you need to name ionic compounds that have multiple oxidation states. Now this involves a little bit of extra work on your part. Number one, you need to recognize it. So this is going to typically happen when you have transition metals or sometimes tin or lead. And in this case we have lead. So this is a post-transition metal with multiple oxidation states. It's going to require a Roman numeral. So we need to use a Roman numeral in their name. PbCl2, we need to use the anion, the Cl, to find the charge on the cation. So chlorine is always 1 minus when it's in an ionic compound. So the Cl is a -1 charge, but I have 2 of them. So I have 2 -1s on the right. So that means I have to have a 2 plus on the left to balance it out. That means I'm dealing with the 2 plus variety of lead and not the 4 plus. So when I write its name, I'm going to write lead, Roman numeral 2, and then I'm going to write the name of the anion, which in this case is just chloride. So this is lead 2 chloride. So things to look for. If the cations have a parentheses, the number in the parentheses is the charge. If the anions end in "ide", they're probably off the periodic table. which means they're monoatomic, one element right off the periodic table, somewhere to the right of the staircase. Now, there are some exceptions of polyatomic ions that end in "ide," but most of them don't. They're going to end in "ate" or "ite," and that means you need to go to table E to find the symbols that are required and also the charge. So let's do some practice here. I want you to write the formula or the name of the following. Pause the video and write these down in your notebook. Give them a try, and when you're ready, unpause it and I'll answer them for you. Okay, let's see how you did. So our first one, iron 3 phosphate. So these ones are easy in my opinion because the Roman numeral tells you the charge. Iron is Fe. The Roman numeral 3 tells me it's a 3 plus charge. I don't need to do any detective work. They've given me the charge in the Roman numeral. Then I need to write phosphate. So it ends in 8, and that should tell me it's a polyatomic ion. So I go to table E and find phosphate, and it is PO4 with a 3 minus charge. So there's my answer, FePO4. Next, I have tin 2 fluoride, another Roman numeral. So I just need to find tin. It's Sn. The Roman numeral 2 tells me it's a 2 plus charge. And my anion is fluoride. So fluoride, it comes from fluorine, group 17, which means it will have a 1 minus charge. So if I just wrote SNF, I would be wrong because these charges are not balanced. All ionic compounds have to have a balanced electrical charge here, and this one doesn't. A 2 plus does not balance out a 1 minus. So I need to crisscross the charges. I'll bring that 2 over to the fluorine side, and the answer is now SNF2. Next, we have potassium sulfide. So potassium's in group 1, the element's K. Look at a 1 plus charge. Sulfide, that "ide" ending tells me it's a monoatomic element. It's sulfur with a 2 minus charge because it's in group 16. So again, this is not balanced. A 1 plus will not balance out a 2 minus, so I need to crisscross the 2 over to potassium side, and my answer is K2S. Next, we have ammonium chromate. So ammonium is a polyatomic ion. It's one of the rare cations. That's a polyatomic ion. The symbol is NH4 with a 1 plus charge. Chromate is also a polyatomic ion. It's CrO4 with a 2 minus charge. A 1 plus doesn't balance out the 2 minus, so we need to crisscross the 2 over to the left. So the answer is NH4 in parentheses 2 CrO4. Next, we have MgSO4. So now you need to write the name from this symbol. So Mg is magnesium, and SO4 is sulfate. And their charge is balanced, so that's why there's no subscripts, besides the 4. The answer is just magnesium sulfate. Next, we have FeCl3. So Fe is iron. You should recognize that as a transition metal. So transition metals, we always need to check to see if it has more than one oxidation state. So you find iron and look in the upper right-hand corner, and it does. So we need to figure out which one it is. So we do that from the charge of the anion. So chlorine is always -1. So if I have 3 minus 1s, that tells me the iron must be a +3 to balance it out. So the answer would be iron Roman numeral 3 and chloride. So let's summarize what we've learned so far. To write the formula for an ionic compound from its name, we need to follow the 3-step approach. You write the symbols and charges for both the cations and the anions. You check to see if those charges are balanced, and if they're not, you crisscross. If you want to write the name of an ionic compound from its formula, you just need to name the cation and then the anion with that "ide" ending at the end. Be aware of cations that have multiple oxidation states. These usually are in the transition metals, also lead and tin. If you have one of these in your formula unit you are naming or trying to write, you need to figure out the charge and write it in parentheses if you're writing its name. If the anion ends in "ate" or "ite, you need to use table E to get the symbols and the charges. I hope this makes sense, and if you have any questions, please let me know.